Now we want to look at a result from the quadratic formula. Remember the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we know that this gives the roots of a quadratic equation. So remember, roots where a curve cuts or touches the x-axis. We can also call them zeros, and because this is where y would equal 0 there. So what we want to look at is this part under the square root sign. It has a special significance for it, because we know when we start to do the quadratic formula, and if we get a negative on this one, we don't get any solutions to our quadratic equation. So that means something to us if we think deeply about it. And so it has a big part to play, because that's the part that causes it, not the minus b and the 2a, but what's under the square root. And we call that part of the equation, this part b squared minus 4ac, the discriminant, because it starts to discriminate between our roots of the quadratic. So it starts to discriminate between our values and what type of solutions and how many solutions we're going to get. Now we use the word discriminate to tell the difference apart. We use this little symbol here, and that is capital delta. It's a Greek letter. So that's what you'll see used as the symbol for the discriminant. So what we're looking at, the idea when the roots of a quadratic equation, when the discriminant's equal to 0. Well, when there's nothing under when the square root has a 0, well, that means we're only going to get one solution, because we just have minus b on 2a. So there's only one solution. And what does it mean? It means that there's only one root. So when we have that, the curve, which is the parabola, touches the x-axis at one point only. So that's what that one means. If we get a discriminant equals 0, we get one solution. It comes down, it's going to touch our axis at one point only. So if the discriminant's less than 0, it means then we can't get any solutions to our quadratic equation, because we try to take the square root of a negative number. That means the curve does not touch the x-axis. So it looks like that, or it may look like that, depending if it's concave up or concave down. So we get one of those two situations. And if we get the discriminant greater than 0, well, there's two solutions from the quadratic formula. So there'd be two roots of the equation. That means we get our parabola cutting our x-axis twice. So that's what we mean when we look at the sign of the discriminant, the part under the square root of the quadratic formula. So what are we looking at here? The sign of the discriminant. If there are two real roots, so two real roots in the number system, and these are the things you're going to see in questions. These are the types of wording you would see. And mathematically, what does that mean? It starts to mean that we get a discriminant greater than 0, because we get two solutions of our quadratic formula. If there are no roots, so that would mean that our discriminant would be less than 0. We'll get a negative number under the square root sign. One real root would be our discriminant equal to 0, because we just get the minus b on 2a. Real roots, well, this is either going to get one real root or two real roots, so two solutions there, which means our discriminant's greater than or equal to 0. What do we mean? And hopefully we know what we mean by this word real, because we're talking about the real number system, where we can't take the square root of a negative number. Two equal roots, well, this is the same as one real root. It's just some text you'll see, and some people consider that there's either going to be no roots of a quadratic equation or two roots, but sometimes those roots are equal, which basically gives you one root. So it means that you're going to get a discriminant equal to 0 there. So it's one real root, two equal roots mean exactly the same thing mathematically. The discriminant's equal to 0. Roots that are unreal, it means they're not real roots. It doesn't mean they're really good. So, a little maths humour. So we get the roots are unreal, the discriminant would be less than 0. And the roots are rational. Now, to get rational roots, we will have our discriminant greater than or equal to 0, because we'll get roots. And then our discriminant is a perfect square. Remember, a rational number is one where we get a fraction. We can write it as a fraction. So anything that's a square root of anything other than a perfect square does not give us a rational number. We can't express it in a fraction. So the discriminant is a perfect square there. So we need that. So it's either 0, 1, 4, 9, 16, so on. It has to be that. If it's not that, one of those, then we don't get a solution to our quadratic equation. So have a look at those as words. You'll see those pop up in a lot of questions. And you've got to be able to make a mathematical statement once you see one of these statements here, because it's all about being able to prove something with the mathematics, and that's where we have to get a start with the discriminant of our quadratic equation.